Okay, so we have a reaction here, and it's an example of what I would call a one-step synthesis problem. So we need to get you to start to be able to do synthesis. And that means if I give you a product that I need to form, can you build it for me? And so these are the very first, very simple versions of that type of problem. Essentially, I am saying, okay, here's a product, build it for me. The difference is that I'm giving you the starting material to build it from. So we are essentially completing the reaction, but instead of writing down the product, what we're going to do is we're going to write the reagents down. So what we need to do is we need to think about what the product is. The product is an alcohol. And so that limits the different types of reactions that I know that make alcohols. I could add acid to an alkene, I could do hydroboration oxidation, and I could do oxymercuration demercuration. I know some other reactions that make alcohols, but they make diols, so I don't need to think about those because this is not a diol. All right, so the other consideration to make is, well, where is the alcohol located? Well, if I take a look, the carbon that the alcohol is attached to is only connected to two other carbons. And if I look at the starting material, the location that the alcohol must get connected to is the location of cross the double bond that's connected to only two other carbons. So there it is. And so this gives us some indication that the reaction proceeds with a particular regioselective outcome. And that regioselective outcome is that it's an anti-Markovnikov addition of an alcohol. So putting all of that together, we know that there's only one reaction that we know that does that, and that's hydroboration oxidation. Hydroboration oxidation produces anti-Markovnikov alcohols, and so that's the solution to this problem.